Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhanani binti Husaini with number metric S60325. So today I'm going to present about the ocean ion fertilization. Okay, this is my table of contents. First, I'm going to start with the introduction. What is ion fertilization? It is a method where iron is introduced into the low-level ion area. But why? Why does iron need to be introduced into the ocean? This is because iron can help phytoplankton to utilize micronutrients. When this happens, the number of phytoplankton will increase. More of the atmospheric carbon dioxide is absorbed, making the carbon dioxide concentration in the atmosphere to be decreasing, thus making the climate more colder. According to the Martin hypothesis, he suggested that the ocean ion fertilization could become an effective method for stimulating oceanic carbon sequestration through the biological pump in iron-limited, high-nutrient, low chlorophyll area. Okay, how did Martin found this finding? In 1993, during the Iron EX1 experiment, near the Galapagos area, they first released the iron sulfate into the 64 kilometers per square of surface water. They used the SF6 as a tracer for iron fertilization. After that, by using the gas chromatography by electron capture detector system, they use it to monitor if there is any changes. And the result is there are only small changes in the chlorophyll A concentration, the primary production, and biomass. Okay, next question is about how did the atmospheric gas composition in ancient time be found? It is through the analyzing of the Arctic-Antarctic ice core. This is because the polar ice sheets have the ability to effectively preserve items from the past. Some of the air bubbles in the ice core can reveal some crucial information about the chemicals and gas compositions. Okay, the main objective of ocean ion fertilization is first to relieve and resolve the problem of global warming. The second, iron can act as an essential micronutrient to stimulate the uptake of macronutrients for phytoplankton growth. The third, it is also a potential technique for efficiently reducing the atmospheric carbon dioxide levels at a relatively low cost. Okay, let's talk about some of the history. Okay, the area of where this ion fertilization experiments is performed is in the Southern Ocean, the Equatorial Pacific, the Subtropical North America, and the Subarctic North Pacific. The reason they chose the Southern Ocean is because it is an important role in the intermediate and deep water formation. It is also the greatest potential of any major ocean basin for carbon sequestration with artificial ion addition. It is also considered as the largest HNCl region in the world ocean. Okay, for the Equatorial Pacific, the scientists chose this area because of its high light intensity at temperatures to promote rapid phytoplankton growth. Okay, what are the relationship between high iron and reduced carbon in an atmosphere? Okay, high iron can help in enhancing carbon fixation. This is because high iron concentration can also increases the production of phytoplankton. As iron can become an energy source for phytoplankton production, when more phytoplankton in the ocean is being produced, more carbon dioxide is absorbed into the ocean. When there is less carbon dioxide concentration in the atmosphere, this causes the climate to become colder. This is because carbon dioxide can trap heat and it can increase the global climate. Okay, so I'm going to talk about the timeline on the experiment between the past, the present, and the future. So for the first, the total number of experiment of the artificial ocean ion fertilization is, the total is 13, 7 in the Southern Ocean, 1 in the subtropical North America, 2 in the equatorial Pacific, 3 in the subarctic North Pacific. And there are 6 in the of the natural ocean ion fertilization experiments. Okay, what are the some limitation and improvement in the specific area? For the equatorial Pacific, based on the bottle incubation experiments, they can exclude higher trophic level, has been strongly criticized due to the possible underestimate in grazing rates and other bottle effects. So how to prove this? We need to require an in situ ion fertilization experiment for the whole ecosystem level. For the Southern Ocean, it is not deemed appropriate because the area is not deemed appropriate because of the vastly different between the environmental condition. Therefore, the Southern Ocean Ion Release Experiments (SOIREE) was performed to test on the roles of iron and light availability. Okay, between the experiments, there's also limitation that's been observed. So the iron EX1, one of the limitation is the subduction of the fertilized patch, and because of the single ion addition. Okay, for the iron EX2, one of the limitation is there is no expert flux measurement in deep ocean, and there is insufficient experiment duration. For the SOIREE, the limitation is because of the insufficient experimental duration. For the ICEN EX is because of the light limitation by storms. Okay, there's also success and unsuccessful experiments throughout the whole experiments. For the successful biogeochemical response is in the iron EX2. This is because there is a shift from a phytoplankton dominated community to a microplankton dominated community. This results in a diatom dominated bloom. This dramatic change is providing the support for the Martin's hypothesis. However, all the other experiments besides 3, including the iron EX2, there's showing the unsuccessful rate between this SOIREE and the ICEN-X. For the present timeline, there are a few side effects in the response of ion addition. The first one is the production of greenhouse gases, which is nitrous oxide and methane. The production of new hypoxia or anoxia in water column. And the third one is the toxic algal bloom from the species of Pseudonitschia. Okay, one of the methods of for tracking and quantifying carbon export flux before is through the sediment trap, and then there's a water column based total deficiency. Okay, there are also some law regulation for the artificial ocean ion fertilization that's been held. Okay, the first one is the resolution LCLP.1, which is being held in 2008, where there is a prohibition ocean fertilization activities until specific guidance could be developed to justify some of the legitimate scientific research. The second one is the resolution LCLP.2, which is made in 2010, which they demand some the primarily scientific research prior to any artificial ocean ion fertilization experimentation. Okay, so the third one is the large scale, the resolution LP.48 in 2013, where the large scale and or commercial AOIF are currently banned by international regulation. Okay, so for the future timeline, there are a few methods where we can improve the experiment. So first one is through the location, where we can conduct the experiment in the center of an eddy structure when grazing pressure is low and silicate levels are high. For the time duration, the observation period must be with minimum of 40 days. This is because short experimental is insufficient to detect influence of AOIF on primary production, primary production and the ecosystem. For the method, the chemical form needs to be, for iron addition, is to be acidified iron sulfate. The iron concentration needs to be 2 until 4 newtonmolar with multiple iron injection. For the timing, it is preferable to do it during the early summer of late December to early January. This is because the phytoplankton blooms usually occur at the south of Southern Ocean during that time. For the effective tracing of fertilized patch, it is better to use both physical and biochemical traces. So the other side effects of AOIF is the decline in oxygen concentration, oxygen content and climate relevant gases. Okay, that's all from me. Thank you.